Many simple rapid diagnostic tests detect specific antigens in biological samples by using an enzyme immunoassay. The purpose of this animation is to explain how a prototype example of this assay works. The enzyme immunoassay can be done in a multi-well microtiter plate or on any other solid adherent surface. I will use the microtiter plate in this example, so let's take a closer look at one of the wells of this plate to see what happens during the performance of the assay. The plate is prepared to perform a particular assay by coating the wells with antibodies that bind to the antigen of interest. Then the wells are filled with the clinical sample, which could be a sample of serum, respiratory secretions, cerebrospinal fluid, urine, or some other body fluid. If the antigen is present in the sample, it will bind to the fixed antibodies. In this example, the green shape represents the antigen of interest, and the other shapes represent other molecules in the sample. However, note that only the specific, or green antigen, and none of the irrelevant molecules bind to the antibody-coated wells. This accounts for the specificity of the test. The wells are then washed out to remove any of the unattached molecules, leaving the antigen of interest stuck to the wells. Now, a second antibody, directed against another epitope on the target antigen, is added. These antibodies are conjugated covalently to an enzyme, indicated by the yellow circle at the Fc portion of the second antibody. They bind to the antigen that's fixed in the well, and this provides a second level of specificity for the assay. The wells are washed again to remove any unbound antibodies, and in the final step, a solution of a colorogenic enzyme substrate is added. The interaction of the substrate and the captured enzyme generates visible color in the solution. At the macroscopic level, the development of color indicates those samples that have second antibody bound to the target antigen in the wells. Thus, the wells that change color are the ones that contain the antigen of interest. In other words, the positive